Okay, a simple connected graph with no cycles. Find the maximum number of edges you can remove from the tree to get a forest such that each connected component of the forest contains an even number of nodes. Okay, as an example, the following tree with a node can be cut at most one time to create an even forest. Okay. We are given we have to find the maximum number of edges that we can remove, so that every component that is formed has an even number of nodes. Okay, so we have to cut all the edges at once only, right? Then only it makes sense. So let's say this one. So if I cut 1 and 2, this one will be odd. That means it doesn't make sense to cut 1 2. So can I cut anything else? No, because 1 1. So 1 6 can I cut? Okay, 1 2 3 4 5 6 and 4. Yeah, 1 6 I can cut. And after 1 6 can I cut anything? Yeah, 1 3 also can be cut. Is it? Yeah, 1 3 and 1 6 can be cut. And how many components will I have? 3. So if I cut e edges, I will have e plus 1 components. Yeah. Okay, so what if the subtree size is odd? What if the number of elements is odd? Then I can never cut this tree into 2 or more parts, such that every part has even number of nodes. So if it is odd, n is odd, then answer is 0, right? There is no edge I can remove such that every other component, because at least one component will have that odd number of nodes. Yeah, makes sense. What is n? Okay, n is even only. Okay, even integer. I think, okay, let's see. So if we are given this tree, from here we can again cut this tree. So can we say we have to divide we have to cut the edges. Can we say, can I cut this edge? So we will have one subtree of size 4, one subtree of size 1 2 3 4 5. No, I cannot. So let's add one more edge. Yes, now can I cut this into 2 parts? So yep, so I can remove this edge. That means I can remove this edge. One subtree will be of size 4, one subtree will be of size 1 2 3 4 5 5. What? 1 2 3 4 5 6 6 and 4. So if I need to do okay, so if I can add more nodes, what will happen? So if I know the answer for a child, can I cut this node? When will I cut this? When will I cut this node? I will cut this node if and only if this child's size is even, right? So can I cut this edge? So 3 and 3 3 6 9 10. Yeah, we can cut this edge. We can cut this edge if and only if. So for any node u, so for any node u, we'll have multiple That means for all v belonging to the children of u, can I say, because it makes sense to cut only those nodes. Let say, so for all v belonging to the children of u, let's say cut the edge between v to u if and only what cut the edge between u to v if and only if size of v is even. Because subtree size is even, so n minus size of u is also even. Okay, it's fine. So can I cut this edge? No. Can I cut this edge? That means for leaf edges we can never cut them. Okay, just above that, can I cut this edge? It will depend on how many nodes do you have. If it has even number of, no, combining this one, so I would need to calculate the size of this node and then decide. So if I cut this node, 3 3 6 3 9 1 10, so if I cut this node, cut this edge, such that I have this component and I have this component, I'm not counting, let's say it has even number of nodes, so it has also even number of nodes. It can be further divided into multiple components, right? So if it is even, it can also be. So if I know the answer of this subtree of this child, that what is the maximum number of edges that can be removed, will it matter? Only the size of this subtree matters, right? How many edges I am removing, it does not matter, because I don't know how many edges I have removed so far in this. If I remove this edge, that will just increase this answer by 1, right? How many edges I have removed from here, maximum edges, such that every subtree is of even size. So for every child, so for every node u, I can go to all the children and ask, can I remove this edge? Can I remove this edge? Can I remove this edge? Yeah. If I can, then I can increment my answer, right? Whatever the answer is from here, it's just incremented by 1, and it will again go from here. So answer should be a global variable, right? Yep, but it will count edges. So can I cut this edge? So I don't know the answer for this edge, for this subtree, but I know the size, so I can cut this edge. Then again go here, can I cut this edge? No. That means I need to know the size. I think I can solve this. So go to every node v of the child of u, and then child of u, and then if size of that node v is even, that means I can cut that edge, right? So I can do answer plus plus. Yep. Let's see. Check the code. And e from and to. What are these? The number of nodes in the tree, number of edges, and starting of each edge, node of each edge. Okay. Let's create the graph. One based or zero based? 10, 1, 2, 3, 4, 5, 6. Okay, go to all edges. Adjacency of from of I dot pushback to of I. Adjacency of 2 of I dot pushback from of I. Okay, I have the graph. Let's supply ADFS from 1, parent is -1. What will we need to pass the adjacency? We need to store the size also, right? Okay, we need to find answer also. DFS only from the parent adjacency vector and vector of integer of what's the size and answer also. What is size? It is nothing but the size of each subtree is 0 initially. It will call, you can say size of this node is 1. Now go to all the children of u. So if b is equal to parent, then we can continue, otherwise otherwise check the size of this node. So if it is even, right? So if that size is even, so can I delete this edge? Can I delete this edge? Can I delete this edge? For that we need the size of this subtree. Okay, first calculate the size. So I think to calculate the size we would need to call DFS on V with parent of U, pass the same adjacency, size and answer. Okay, now I have the size of V. If size of V is odd, if size of V subtree, size of V is odd, that means I can delete this edge. Should it work? That means I can delete this edge. So if I go, so it will go here, DFS will go here, will go here, it will return 1. So if the size is, so it will not increment the answer, it will not increment the answer, it will not increment the answer. From here it will go here, 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 here. Now when it come back, so size of this will be 4. So it will say that yes, this for this subtree there is one edge that can be deleted, such that one edge that can be deleted to make this as 4 and remaining subtree as one component, and this subtree is one component, so answer is incremented by 1. Now it will go here, so it will say can I delete this edge? So it will ask the size. So that means in this remaining component, if I delete this edge, the second component will be this one. Yeah, so size is if even, I think, yeah, it should work. It should work. Okay. Oh what the, 10 test cases failed. Okay, what's wrong? What's my answer? Output is 9, expected is 1. Oh, I'm not updating the value of u, its size will increment. So dp of v, not dp, it is size. It should work now. What's wrong? With the size of v, size of every subtree is 1. So if it is 1 and 1, so if it is even, then only do answer plus plus. Otherwise, is my adjacency right? Correct. So adjacency is number of edges. Go to all the edges. So from and to and from. Okay, answer is 0. 1 minus 1, adjacency, size and answer. Okay, size should be passed as reference, right? Because it will, otherwise it will remain 0 only. So 0 and 1 is 0, and negation of that is 1. That's why it is counting the number of edges, not that. Yeah. Now if it doesn't work, okay, it is working. Great.